Hello students, today we have to start with chi-square test. As you know, there are different type of testing of hypothesis are there. Out of those testing of hypothesis, some are to be categorized as parametric test and some are non-parametric test. Parametric test means where there existence of some parameter which we are going to be tested. But in case of your non-parametric, those parameters are not given. In parametric, the data is to be collected either in terms of your ratio scale or interval scale. But in case of your non-parametric, the data is to be collected either in terms of your nominal scale or ordinal scale. There are various types of parametric tests are there, like t-test, z-test, ANOVA, and so on. And in the same manner, in case of your non-parametric test, there may be existence of your chi-square test, sign test, Ron test, rank test, etc. Out of those non-parametric tests, we have to start with the first non-parametric test of it, that is called as the chi-square test. Actually, it is chi-square. It will be pronounced as chi. Let's say, you know the term what is sky, S-K-Y. If you pronounce sky without S, then it comes to be chi. So it is a chi-square test, right? And the chi-square test, actually it is nothing but the square of standard normal variate. We know the standard normal variate is to be x minus mu divided by standard deviations. The square of it, the sum of the squares of it is to be known as the chi-square test. Here, the data, the sample is to be collected randomly from a normal distributions with the mean mu and standard deviations sigma. So it will be written as chi-square that equals to summation of x minus mu divided summation of the square of x minus mu divided by standard deviations, right? And the chi-square test can be applied in two ways, specifically according to the the utilizations of your management students. It to be chi-square related to the goodness of it and chi-square for the independence of attributes. Actually, in order to entering into the solutions pattern of your chi-square test of your goodness fit and the independence of attributes, the conditions must have to be remembered where we have to applying the term the chi-square test, right? The first of all, the data is to be collected in the random basis. The randomly collected the data. Second, the sample must have to be independent. All the sample must be independent, right? Next, there is no such group. The data what we collected, there is no such group which is to be going to be less than 10. If it is less than 10, we have to add together. We have to add together so that it becomes greater than 10. So to try to convert the minimum way that not a single group going to be less than 10. Okay, the observed outcomes is to be less than 10. And the next most important point, the number of items which is going to be required, that is the number of samples which is going to be, that is the sample size, it will be normally at least 50. So we try to take into account the normal standard component is to be the 50. 50 is to be the at least 50 the data must have to be there. Otherwise, we are calculating it, but the interpretations part it is not so accurate, right? Now, how to finding out the critical value? As in case of your normal basis, if you take into account the critical component of it, it is assumed to be a normal distribution, but it is not a normal distribution, right? And if it is lie inside the acceptance zones, we have to accepting it. If it is lie in the rejection zones, we have to rejecting it. So you have to finding out with the p-value. If you're analyzing the data with the SPSS, that is the statistical software for the statistical package for the social sciences, In that case, we have to considering the p-values, or you can calculating the things. Calculated value you have to calculate with the help of the chi-square, compare with the critical value. That means with the table value, with the certain degrees of freedom and level of significance. If it is, let's say if the calculated value is to be more than the critical value, it is highly significant, we have to rejecting it, otherwise we have to accepting it. So these things we have to always remember. And the concept is to be acceptance zones and the rejection zones if you graphically are representing it, but it is not a look like a normal distribution, rather it is an asymmetrical distribution today. Now we start for the chi-square for the goodness of it. Actually, the chi-square for a goodness of it, to interpreting the results, we require two things. One is your observed frequency, next one the expected frequencies. E stands for the expected frequency and O is the observed frequencies. And we have to calculating the given outcome, the given informations inside the problem, normally it will be the observed frequencies. And we have to calculate the expected frequencies. Now, expected frequency is to be calculated by considering those observed frequencies itself. And we have to take into account the degrees of freedom, the number of outcome, the number of sample less than 1 and minus 1, right? But in case of a contingency table, that means if it is a cross tabulation, if it is given, the data is given in terms of the cross tabulation, in that case number of row less number of 1. That means the degrees of freedom can be calculated row minus 1 into the column minus 1, right? But right now, as we take into account the goodness of fit, therefore we have to take into account the degrees of freedom, it will be n minus 1, and considering the level of significance, whether it will be 5% level of significance or 10% or the 1% level of significance. Let's start with one numerical problems. If you take the numerical problem is given to you, suppose a die is to be thrown 132 times. 132 times a die to be thrown, and following results are to be obtained. That means we know in a dice that the sides are there 1, 2, 3, 4, 5, 6. We have to roll the die how many times? 132 times. 1 occur 16 times, that is the observed frequency. 16 is the observed frequency. 2 occur 20 times, that is your observed frequency. So 3, 25, 4, 14, 5, 29 and 6, 28. These are the observed frequencies, right? Now the question to be arises whether the die is an unbiased dice or it is a biased dice. In order to test the biasness of the dice, we have to enter in the chi-square test, because the data is to be given, the outcomes are given. How many times 1 occur, how many times 2 occur and so on. These are the observed frequencies. We have to calculate the expected frequencies. How to calculate the expected frequencies? We have to add the observed frequency divided by how many, numbers to be there, it to be 6. While you're dividing it, we find 132 divided by 6, we find it is 22. We assuming that all the observed frequencies are to be, expected frequencies to be 22. It's the given data is to be that number of turn of 1, 2, 3, 4, 5, 6. How many times to be occur? These are the observed frequencies, and by dividing the number of observations by the how many turn up to be there, then it is 6. We have to dividing by 6, we obtain all the expected frequencies to be 22. Now, if all the expected frequencies 22 we obtain, E is 22, O is to be, these are the things O, that the 16, 20, 25 and so on, then our target is the chi-square. Chi-square is nothing but O minus E whole square. We have to take the differences first, then the squaring it and dividing by the expected frequency. We have to add this particular column. While you're adding this column, we find the outcome is to be 9. Now, the chi-square value is to be 9. Now, whether we are accepting or the rejecting it, whether the die is biased dice or unbiased dice, because we have to take the null hypothesis, no, the coin to be the unbiased one, the dice to be the unbiased one. Now we have to test it, whether the bias or unbiased. So considering the degrees of freedom, what is the degrees of freedom? The n is 6 plus 1, that is a 5, and we have to calculate it values to be 9. Corresponding to this 5 degrees of freedom and 5% level of significance, the critical value, the table value, we obtain 11.071. This is the critical value which is extracted from the table. Calculated value is 9. 9 is less than, the calculated value is the less than the critical value, so it is the less significant. If it is less significant, we have to accept the null hypothesis. That means, so here we have to conclude that dice is to be unbiased, because we take the null hypothesis that dice to be unbiased. Alternate hypothesis, dice to be biased one. Okay, so right now what you find, the calculated value is to be less than the critical value, therefore to be less significant, we have to accept the null hypothesis. So this is the way we have to solving the problem. The first of all, if the problem is given, we have to study the problem systematically, what are the observed frequencies are there, then calculate the expected frequency, then you have to move to the chi-square value. But prior to that, you have to defining the term, what is null hypothesis, what is alternative hypothesis, what is the degrees of freedom, and the level of significance, there are the critical value. We have to calculate, to compare the calculated value with the critical value. If the calculated value right now in this case, calculated value is 9, critical value is 11.071. So calculated value is less than the critical value, less significant, we have to accept the null hypothesis. Now, if we move to the next problem, here the data is given that the sample analysis of the examinations results of the 500 students was made. That means in an exam 500 students to be appear. It was found that 220 students are failed. 170 secured third division or third class, 70 were placed second class, and rest 20 got the first class. Are this figure commensurate with the general examinations result of the ratio 4:3:2:1? These are the standard results. The standard component is to be, if you take the 4 plus 3, 7 plus 3 to 10. So the out of 10, 4 must be there, 4, 3, 2 and 1. This is the ratio. In that particular ratio, it will be categorized, either is to be failed students, first class student, second class student and third class student. But what are the observed case? Out of the 500 student, observed term to be 220 is to be failed, that is the observed frequency. 170 again is the observed frequency, third division. 90 is the second division, that is the observed frequency. These are the observed frequency, but the expected frequency is of the ratio 40% or the 40 out of 4 out of 10 is to be out. If you take into account 500 students, 500 into 4 upon 10, that much student we have to calculate the expected frequencies for your failed candidate. Similarly, 3 upon 10 into 550, in that pattern you have to calculate the expected frequencies. Question to be arises, is it a match with all other figures, the observed frequencies that commensurate with the general examinations result? We have to take the null hypothesis, no it is not so, right? Then we have to set the alternate hypothesis, yes it may be, right? And the table value is already given inside the question, that the 7.81 at the 5% level of significance, with the degrees of freedom is how many? 3, because the 4 options are there, fell, first division, second division, third division, right? There are the 4 options, that means the 3 degrees of freedom and 5% level of significance, the critical value is given to you 7.81. Now we have to calculate the observed frequencies, expected frequencies and the chi-square value. Then while you're moving the calculating the, first of all, the expected frequencies, the 4 upon 10 out of a 500, that is 200 are to be failed. Similarly, third division is to be like that and so on. So these are the expected frequencies. But observed frequencies is already given. So we have to putting those two along the side of it. Then we have to proceed with the table. So the table, we have to categorize the failed, third, second and first. These are the observed frequencies. Out of 500, 220 got failed, 170 got third division and so on. These are the observed frequency. Right now you calculate the expected frequencies, 4 upon 10 into 500 like that. So thereafter we are going to calculate, that is called the chi-square value. And the chi-square value is going to be calculated like O minus A whole square divided by E. That is the chi-square value. What is the chi-square value? Chi-square value is to be 23.667. But calculated value is this one, or we know the critical value is given is very less than this one. That means the calculated value is much more than the critical value. That is highly significant. We have to reject the null hypothesis. So what the interpretations part? The interpretations part it will be like this way. As the degrees of freedom is to be true and 5% level of significance, critical value as is given inside the problem, it will be 7.815. So we find that it is highly significant, we have to reject the null hypothesis. Hence, we have to conclude the data are not commensurate with the general examination's result. Right? We have to reject the null hypothesis. So, this is the way to handle the questions related to the goodness of fit. Now, this is another problem is given where the solution is to be simultaneously given to you. In this case, as I cited in the very beginning, all the observed frequency definitely is to be more than 10, right? But in mark the problem, in this particular problem, class are A, B, C, D, but observed frequency is 8 and 4, mark it, the first and last, they will be less than 10. So, we have to add the first with second, A with B, that is the 29 with 8 and D with E, that is the 15 with 4. While you are adding together, then observed frequency we find it is more than 10. And in the simultaneously you have to the adding the expected frequency, because inside the problem expected frequency is also given to us. So we have to adding that 24 plus 7 and 24 plus 7 in the first AB and thereafter the last two, that is DE. Then after that we have to find the terms observed frequency and the new expected frequencies. Considering this new observed and expected frequency, we have to finding out the chi-square value, and the chi-square value to be this one. Then we have to comparing the calculated value with the critical value. Here the degrees of freedom is to be 1, 2, 3, 4, 5, 5 plus 1 is 4 degrees of freedom and 5% level of significance. Considering that, comparing the value, if the calculated value is more than the critical value, then we can say that it is highly significant, otherwise it will be less significant. As you know, if it is highly significant, reject the null hypothesis, otherwise we have to accepting it. Now, move to the independence of attribute. Actually, independence of attribute means whether there is any associationship takes place between the variable or not, so that we are going to be calculated. Take for example, suppose you do you face some sort of diseases, you find you consuming the let's say medicines. You may cure with consuming the medicine, you may cure without consuming the medicines. Now the question to be arises, is there any associationship? Is there any associationship between the consuming the medicine and curing the disease? That we are going to be calculate. So that things to be, is there any associationship? That is the term what is called the independence of attribute. Whether they are to be dependent or independent to each other. That we are going to be calculate. And either the data is given in terms of your observed frequencies and expected frequencies. Again, it will be given either in terms of your cross tabulation basis or may not be a cross tabulation basis. Suppose if it is given to the cross tabulation basis, then how we have to calculate direct method and in the with the help of the previous method, that is the summation of O minus E whole square divided by that method we can calculating it, right? Let's proceed with that. This is the formula for to calculating the direct method with the degrees of freedom, that is called the number of row less 1 and number of column less 1. And if you are entering into the 2 by 2 contingency table, that is the easy way to explaining the concept of your independence of attributes. Here there is the 2 by 2 contingency table, that means there are the two A, B, C, D, they are the observed frequencies, right? A, B, C, D, they are the observed frequencies. Considering those observed frequencies, we are going to be calculating the terms. Here addition of the row is A plus B, second row addition is to be C plus D, and the addition of the column is A plus C and addition of the second column is B plus D. If you add the whole number, that is the whole observed frequency, A plus B plus C plus D, right? Considering that, we have to going to enter into calculating the first of all the expected frequencies and how to calculate the expected frequency of the first column, that is the first row first column, that is for A. For E, the expected frequency for A is to be row total, that is A plus B, into the column total, that is A plus C, divided by total number of observations. Okay. Similarly for the B, it is the row total into the column total divided by N. Similarly for the C, row total C plus D divided by column total A plus C divided by N. And similarly for the D, it is the row total C plus D divided by column row total is the C plus D into column total, that is B plus D divided by N. That is the way to calculating the expected frequencies. Thereafter, obtaining the observed frequency and the expected frequency, straight way to calculating the terms what is the chi-square value. Okay, or we can applying the direct method to calculating it. The direct method means n whole into AD minus BC whole square divided by row total into column totals. So all the row total values and the column total values are going to be the multiplied to each other, and considering that particular terms, we have to calculate the chi-square value. So the chi-square value can also be calculated with the help of these direct methods also, right? Or we can, using this particular terms, expected frequency of A is to be, that is the row total into column total divided by n and so on, and the degrees of freedom is to be, as you know, it is by number of row less 1 into the number of column less 1. Considering that, we have to calculate in the term the degrees of freedoms also, and the level of significance, as you know, inside the question is given to you whether the 5% level of significance or the 1% level of significance or 10. According to the question, you have to proceed. Let's just start with one numerical example to explaining the whole things. Suppose there existence of 1000 students in a college. They are to be means we are going to be test their IQ level and economic condition. Is there any relationship between or association between the IQ level and the economic background of the house? We have to take into account 1000 students studying it in the high IQ level, low IQ level. It may be economically rich or economically poor. So all total 1000. So 460 students, the rich having high IQ level, and 140 students of your rich having low IQ level. That means all total there are the 600 richer people are there. But out of 600, 460 are high IQ level and 140 are low IQ level. And in the same manner that of the poor is given to you. Now the question to be arises is there any association between the IQ level and the economic background of the home? That we have to take into account. We have to say no, they have to be completely independent to each other. We have to take the null hypothesis. There is no relationship. That means the both the term, that is the IQ level and economic background of the home, are completely independent to each other. But the alternate hypothesis, no, there is some link. They have to be independent to each other. And what is the degrees of freedom? As you know, it is how many observations? 4 observations are there. Rich high, rich low, that is the 2. Rich poor and rich. That is called the poor high and poor low, that is the 4. That is the ABCD. These 4 are the ABCD. And the 4 is the number of observations, that is called the observed frequency less 1, that we have to normally calculate the degree of freedom. But in case of your contingency table, we have to consider here number of row less 1 into the number of column less 1. And 5% level of significance is inside the question. The data is not given whether the 5% or 1%. By default, we have to take into account 5% level of significance. Considering that, we have to calculate all the expected frequencies, that is the row total into column total divided by total number of observations, and each and every observed frequency corresponding to that we have to calculate the expected frequencies. And we take the null hypothesis that the two attributes, that is the economic background and the IQ level, those have to be completely independent to each other. And alternate hypothesis, no, it is not so. Okay. Thereafter, once we collecting the observed frequency and the expected frequency, we are putting inside the table. Then we have to calculate the chi-square value. While calculating the chi-square value, the outcome is to be 31.74. Now, what is the critical value? With the degrees of freedom and 5% level of significance. Degrees of freedom is how many? Row, 2 rows less 1, that is 1, 2 column less 1, that is 1, 1 into 1, it is 1. 1 degrees of freedom, 5% level of significance, and the critical values is to be given to 3.84. And your calculated value is to be 31.74. That means the calculated value is more than the critical value. So it is highly significant, reject the null hypothesis, right? And the alternative method, you can follow the direct method. So n whole into AD minus BC whole square divided by row total into column total. We find the same outcome, same result to be there. That is the 31.74. Okay. And same conclusion to be there. So we have to reject the null hypothesis. Hence we conclude that means there is a strong association between economic background and the IQ level of the students. Okay. So this is the way to calculate the independence of attribute. Calculate the value of the chi-square to study the term independence of attributes as well as your, that is called the goodness of it. Both the terms we have to complete right now. Now, this is another problem. Here, the problem is given the vaccine and non-vaccinated. It may be anthrax to be, the smallpox to be attacked and smallpox is not attacked, right? In this case, also it is given to you 5% level of significance is given to you and degrees of freedom, as you know, the 2 rows and 2 columns, that is the 1 degree of freedom. And we have to taking into account, we can solve it also, okay? Now, what is Yates correction? Actually, Yates corrections, as you know, it will be applicable only in case of your 2 by 2 contingency table, not in any other type of contingency table. And where it will be applied? If any particular observed frequency is to be less than 5. Any particular observed frequency. Inside the table, 2 by 2 table is that. Inside the table, any particular, like either A, B, C or D, any one is to be less than 5. Then we have to apply the term Yates corrections. How to correcting it? The Yates correction can be applied where we find which one, whether the A, B, C and D, out of these 4, which one it will be less than 5, add 0.5 to it and adjust the row total and column total in such a way that means it will remain the same, right? That means if you add a particular point, let's say you are adding 0.5 any particular cell, the corresponding the other cell to be adjusted so that there is no way the changes to be occur in case of a row total and the column total. That will remain the same, right? Let's start with an example and explaining it. And by making the Yates correction, we have to calculating it. Without making the Yates corrections, we also be calculating it. Let's start with the problem. Here, it is given to you. Again, vaccinized concept with the died, the goats that we going to be the died in the anthrax and survived, and they are to be, provided the vaccines and then to be provided may not be the vaccinized. And inside the term that the total other 24 goats are there, and out of them the vaccinized the term going to be died is to be 2 and survive is to be 10, then total it will be 12 to be vaccinated and 12 to be not vaccinated. And in case if you are not vaccinated, it's exactly the same proportion 6 and 6. That is the 6 number have to be died and 6 number will be survived. Now the question to arise is there any link between the vaccinated and the survived component of your anthrax diseases? You say no, it is not so. Right? There is no, that is both the terms are completely independent of each other. Then we have to proceed for the solutions. But remember, we can proceed directly, we can find the solutions, or we can make the Yates corrections. Then how you have to make the Yates corrections? Here you find out of those observed frequency A, B, C and D, that means here is to be 2, 10, 6 and 6. Out of those 4, one observed frequency in the first cell is going to be less than 5. Here we have to adjust it. That means we have to add here we have to add 0.5. If you add 0.5 here, then it turns to be 9.5 because if you add the terms 0.5 to be here, that is the 2.5 and 2.5 and the 10, it is the 12.5. Therefore, you have to subtract it 0.5 here. Thereby, it will be going to be 12 as such. But if you add 2.5 here, 0.5 added to be here, then you have to deduct it 0.5 to be here. That means it becomes 5.5. So that the addition need to be remain the 10. Similarly, as you know, in this case, we have to subtracting it. As you have to subtracting it, that means we have to add to be here. Then add means the total terms to be remain again it will be 16. So that the way in such a manner you have to adjust. There is no way the changes in the occur to be takes place in that total row and total column. Let's start with the calculations part. Observed frequency, we know how to calculate the expected frequency, the row total into column total divided by number of observations. Here, first we have to calculating without any adjustment, right? Then after without any adjustment, the calculations part it will be takes place. Your observed frequency 2, 10, 6, 6. Your expected frequency calculate like this, and we chi-square value is to be 3. Right? Here your chi-square value is to be 3. And you have to concluding the term also like that way. Your chi-square value is to be 3. Degrees of freedom is to be 1. 5% level of significance is the 3.8. As it is the 3.841, this is the critical value and the calculated value this, calculated is less than the critical value, it is the less significant, we have to accept the null hypothesis, right. So that is the concept without Yates corrections. Now if we undertake the Yates corrections, what is the outcome to be there? Now you have to add 0.5 to the 2 and so on. While you are adding it, just mark it here. Here you have to add, it becomes 9.5, it becomes 12. If you add to be here, you have to subtracting, it turns to be remain same. If you are subtracting here, you have to add it, remain it to same, right. So this is the case of your adjustment of your Yates correction. Now considering this observed frequency, we further calculating the expected frequencies. We can calculate the expected frequency in the same process and proceed to the solution. We find solution to differ. In the previous case, outcome is to be 3, but here outcome is to be 1.6. The value have to be differ, but conclusion part is remain the same. In that case, we know the critical value is 3.8. Critical value is 3.8, calculated value in the previous case 3, right now it is a 1.68. That means the calculated value is less than the critical value, it is less significant, we have to accept the null hypothesis. The same conclusion it will take place in the both the cases. Okay, so this is all about what is called the chi-square test. So in case of the chi-square test, as you know, it is a non-parametric test and we have to calculate the two things of it. One is called the goodness of it and second one the independence of attribute. And in the both the cases we also how we have to make the adjusted the observed frequency in the previous case. I mean in case of your goodness of it, if anyone observed frequency if you found is less than 10, you have to add together to the corresponding frequencies. Thereafter you have to calculating the term chi-square value. And in case of your contingency table, with the help of your that is independence of attribute, in here we have to applying the term what is called the Yates corrections. Okay, thank you for today. Thanks.